In our last video for this chapter, what we want to do is we want to talk about descriptive measures for populations and how we might use samples to help us tell something about those populations given our averages, given our standard deviations, and given all the other information that we've been given. So now let's put it together, right? If we talk about a population mean, one of the differences, of course, is the notation that we use. For a population mean, we use the Greek letter mu. This is our Greek letter mu. The way that I remembered is it looks kind of like a U with a long tail. And of course, what sound does a cow make? It goes moo. All right, so that is our population mean right there. And our population mean, we take the sum of all of our population data points and we divide it by capital N. Capital N is the entire population size right here. So that is one difference between how we get it. But it's still a mean in the sense that it's an arithmetic mean. We take the sum of all the values in that population and divide by the size of the population. For population standard deviation, the only real difference is in the formula right here, and I'm going to point it out down here. You'll remember that when we did this by hand, we divided by small n minus 1. That was our sample standard deviation. For our population standard deviation, we use the Greek letter small case sigma to represent that. And our standard deviation for the population is the sum of our observations minus the mean squared divided by the population size, and then take the square root of that whole shooting match and you've got it. Now, that's kind of long. This is the reason that we have something like Excel that's going to help us do that, and we're going to demonstrate that in a bit. Essentially, the relationship right here is that for our population data, right, if we said the weights of all 120 milligrams Xenocal capsules, right, a standard deviation sigma, the standard deviation for our sample, S, right, is going to be a little bit smaller than that population data. That's why we have to divide by n minus 1 to compensate for that difference in sizes, right? So when we divide by n inside of our formula, n minus 1 gives us what we call a degrees of freedom and a chance to balance out that, compensate for that difference in the population versus sample size. Now, a big part right here is recognizing what is the difference between a population and a statistic. A sample, one is the describer parameter. A parameter is a descriptive measure of a population. So if I said I wanted the heights of all U.S. males, adult males, that would be a descriptive measure of the entire population, and we would call that a parameter. A statistic is when I would say, let's find the heights of 1,000 men, right? 1,000 U.S. males, that would be a statistic. So a statistic describes something about a parameter, and we're interested in using this information to get it. One way of measuring where a piece of data lies in comparison to either the population or the sample is to use a standardized variable. We call it a standard score sometimes. A Z-score. And the way it goes is that for any particular value of x, we're going to subtract the mean and divide by the standard deviation. This allows us to compare two completely different populations in terms of the population that the data is being taken from. So this is actually a very handy thing for us, right? Another way of looking at this is that the Z-score tells us how far away any one single piece of data is from the mean in terms of the standard deviation. In other words, we can say how many standard deviations away from the mean is that piece of that variable. Right? So we're going to do that. We're going to use our problem number 5, and we're going to use Excel to help us get this information. We've got information concerning Jessica Lange, who won her Best Oscar at age 45, and Sean Penn, who won an Oscar for Best Actor first at age 48. Mean age, standard deviation for Best Actress and Best Actor, and then calculate the Z-score for both of those. So we're going to open up the data set from Canvas. So we're going to go to Canvas right here. We're going to open up the data set OSCR, Oscar, right? So we're going to go to our data set Oscar here. I open it up here. There's my library. I open it up from my data set right here. And I found, there it is, Oscars, actors, and actresses. This data set is a population, again, because it contains all of the ages of our best actors and best actresses for all the actor and actress Oscar awards ever presented up until the time this book was written. So we're going to consider this our population. So this is our actresses, this is our actors. And the information we want to find is our mean, our median, our standard deviation. And then what we're going to do is we're going to find a Z-score for each of these two, and we're going to do this using Excel. So I'm going to show you how that's done. Okay, for mean, right? The mean score, we're going to get our average. So it's equals average, right? That's our mean, average, right there. And the data range went from cell 2 all the way down, highlighting it, all the way down to cell 83. Close that data set right here, and then go ahead and take that average. And here it is. The average actress age for these Oscar winners was 35.88 years, right, when we're added to the nearest hundredth. Let's get our median sort of the same way. It's equals median. Double click on that. And we're going to enter our cell range of A2 to A83 in this case. And then our standard deviation, since this is a population standard deviation, we're going to enter equals STDEV dot P. All right, be very careful on which one you're using when you're using it. Again, we go A2 all the way down to A83 in this case. And there is our standard deviation. So we're going to enter that in for the actresses. Now, if we wanted to, right, we could actually rewrite all these formulas one by one, but I'm going to show you a trick. In Excel, if we want to copy the same formulas over to the next column and just do the same calculations, we're going to put our cursor right over where that little bottom corner is, and we're going to left click on that, hold down the mouse button, and we're going to drag that all to the next column. So it looks kind of like this when I do it. You see a big heavy green outline go to both of those cells, and look at what happens. Oh, our formulas have been copied, right? And so we're actually finding the average of our actors at 44.12, our median actor age of 42, and our standard deviation of 8.94. That's special, right? That saves us a lot of time. Okay. Now Z-scores. Let's do our Z-scores right here. We said Jessica Lange was age 45. Sean Penn was age 48. All right, so this is our ages right here. All right, so what we're going to do is we're going to write a formula for our Z-score. The Z-score is found by taking the difference between any X value. So we're going to take Jessica's age as X. We're going to subtract our mean, 35.88. Close that parentheses, right? It's equals the difference between those two divided by the standard deviation. So here's our standard deviation. There it is, 0.83, right? Now we're going to calculate that for Sean Penn. So I'm going to copy that over, and 0.43. Ah, interesting. Okay, so let's take this data and transfer it on over to our handout. And the question was, relative to their genders, who was younger when winning the Oscar, Jessica Lange or Sean Penn? Well, according to our Z-score says that Sean Penn was within 0.43 standard deviations away from his gender's mean, from the actors' ages. Jessica Lange was 0.83, so relatively speaking to her gender's standard score, she was a bit further away, right? 0.83 is a higher number than 0.43. So comparing those z-scores is how we can compare two different populations and tell whether one value is farther away from the mean than the other. And so relative to their ages, Sean Penn was actually younger as compared to Jessica Lange at her first Oscar. All right, good luck, and I'll see you in class this week.